Hi friends, this is Vishnu here. Welcome to my channel Tips, Tricks and Concepts by Vishnu. Many students have asked me the doubts on rain man problems, umbrella women problems, then umbrella boy going on a bicycle problems and so on. So in this video, we will be discussing how to solve such rain umbrella problems very easily. Okay, usually in most of the books it's given in a slightly complicated manner. I think that's why the students are not able to do such problems very easily. So in this video, I will just tell a simple trick to solve such problems, and also let's solve 3 problems together. Okay, so let's first discuss the tricks that is needed to solve such problems, which usually comes as CBSE or state board exam questions and also as entrance questions. So first of all, whenever you encounter such problems, you just illustrate or you just draw the diagram as an arrow mark. Okay, if the boy is running, you just show him by an arrow mark the direction of the running, and also the rain falling down vertically or in any direction as an arrow mark. Okay, you don't just directly go to the vectors, you first draw the arrow marks. Okay, so the next step is to convert them into a vector diagram, that is just join the initial points of each of these arrow mark. Okay, now to find the direction to hold the umbrella, the vector needed is nothing but the velocity of rain with respect to the man or the lady or the boy or the girl and so on. Okay, so now what is this velocity of rain with respect to man? That is nothing but when we take the concept of relative velocity, if VAB is the relative velocity of A with respect to B, we write it as VA minus VB, right? So in a similar way, velocity of rain with respect to man can be written as velocity of rain with respect to ground, VR, minus velocity of man with respect to ground, that is VM. Okay, so what we have to do is just to reverse the vector of man. Okay, that is, we have drawn an arrow mark for the velocity of man, right? So we just reverse it. Now what we get as a resultant is our rain, okay, with respect to man, and hence the direction to hold the umbrella is to just against it. Okay, is to just against that resultant that we get now. Okay, we can make it clear by using 3 different types of questions. Now the first question, that is, rain is falling vertically with a speed of 30 meters per second. A woman rides a bicycle with a speed of 10 meters per second in north-south direction. What is the direction in which she should hold her umbrella? Here I am not giving any options because we can encounter it as a board question as well as an entrance question in the same manner. Okay, so firstly let's draw the arrow diagrams generally for the woman and also the rain. Okay, so the rain falling vertically and the woman riding the bicycle. Though the direction is given as north to south direction, we need not bother about it because we just see a practical case here, that is a woman riding a bicycle on the road. Okay, now it's a random diagram. Now just join these two, we get like this, and here again we have to find the velocity of rain with respect to the bicyclist or the woman. So as I have said in my second point, just reverse the arrow mark of the woman. So we get like this, that is the reverse is represented as a red arrow. Now our third step, that is the resultant of this vector diagram will be the velocity of rain with respect to the woman. So in which direction should she hold her umbrella against this resultant? So always we tell with respect to the vertical. So we get this angle theta with the vertical as our required answer. So here we have tan theta is equal to velocity of woman by velocity of rain. So we have 10 by 30. Okay, 10 meters per second is the velocity of the woman, and also 30 meters per second is the velocity of rain. So tan theta is equal to 10 by 30 or 1 by 3, or theta is equal to tan inverse 1 by 3. Okay, and also to tell the direction more specifically, we can tell that since the woman is riding in the north to south direction, we can tell that the woman should hold her umbrella at about tan inverse 1 by 3 with the vertical towards the south. Now the next question, on a certain day the rain was falling vertically with a speed of 30 meters per second. The wind starts blowing after some time with a speed of 10 meters per second in north-south direction. In which direction should a boy waiting at the bus stop hold his umbrella to save himself from rain? Here there is nothing to complicate, a very easy question. There is the rain falling down at 30 meters per second and then the wind blowing later at 10 meter per second. So we have to just find this angle of resultant with the vertical. That's all. That is nothing but tan theta is equal to 10 by 30. Now the next question. This question may seem a little difficult, but we can solve it in an easy manner. Okay. We have a man standing on a road has to hold his umbrella at 30 degrees with the vertical. To keep the rain away, he throws the umbrella and starts running at 10 km per hour. And then he finds that the raindrops are hitting his head vertically. Then the speed of raindrop with respect to the moving man is. Okay, you can also be asked with the velocity of raindrop with respect to the ground also. Okay, so let's do the question. First of all, as I have said, just draw a random diagram. Okay, so first of all, the rain with respect to the standing man was like this. Now he starts running with a speed of 10 km per hour, and then he feels that the raindrop is falling on his head vertically. So the diagram will be like this. So here, though the diagram is like this, when considered in our initial condition, we can see that this angle is 30 degrees. Okay, so the very easiest method to find the velocity of rain with respect to the moving man will be, we have tan 30 is equal to Vm divided by Vrm, right? That is opposite side by adjacent side. Okay, so tan 30 is equal to 1 by root 3, and we have Vm is equal to 10 km per hour. So we have Vrm is equal to 10 root 3. Okay, 10 root 3 km per hour. Now, if we have to find the velocity, actual velocity of rain, that is velocity of rain with respect to the ground, we just need to find the sin 30. That's all. So some may have doubt here that why this angle is 30 degrees. No need of any doubt. Just consider the initial condition alone. There we have told that the man was holding his umbrella 30 degrees with the vertical. So it is the 30 degree angle, and later that vertical became the velocity of rain with respect to the man. That is after he ran. Okay, only after he ran that vertical became the velocity of rain with respect to man. Okay, this is the easiest way to approach. Okay, so I hope you have understood the concepts very clearly, and we have also discussed 3 possible variations of the question that can come for your exams, be it board exams or your entrance exams. Okay, just follow our initial principle. That is, first of all, just draw a random diagram, then convert it into vector forms by joining the initial points, and then reverse your velocity of man or velocity of lady or velocity of cyclist or whatever it is. So if you haven't subscribed my channel, please subscribe it, and bye bye for now.